Somewhere, 12.5 billion light-years away, there's a galaxy sitting on a secret. Not one black hole. Not two. 3, all feeding at the same time, in the same galaxy, and until a few days ago, nobody on Earth knew they were there. Let's get into it. The galaxy is called J0148-4214, and honestly, the name tells you nothing, so forget it for now. What matters is where it is, and more importantly, when it is. Because when you look 12.5 billion light-years away, you're not just looking far, you're looking back in time. The light hitting our telescopes right now left that galaxy when the universe was only about 1.2 billion years old. That's roughly 8% of the age of the universe today. So this isn't a galaxy as it looks now. This is a photograph of the early universe, still in transit, only just arriving. And inside that photograph, astronomers found something nobody had confirmed before: 3 actively feeding supermassive black holes, all in one galaxy. Here's how they even found it. The team, led by researchers at the Max Planck Institute for Extraterrestrial Physics, used an instrument on the James Webb Space Telescope called NIRSpec, a spectrograph that doesn't just take a picture, it splits the light coming from different points in the galaxy and studies it piece by piece. Think of it like this: instead of one blurry photo of a crowd, you get to separate every single voice in that crowd and listen to them one at a time. That's roughly what spatially resolved spectroscopy does with light. It let them pull apart signals that would have looked like one single messy blob to any earlier telescope. And when they separated it, they didn't find one bright core. They found 3. 2 of them sit close together near the center of the galaxy, only about 620 light-years apart. To put that in perspective, that's incredibly close on a cosmic scale, practically neighbors. The third one is further out, sitting almost 5,500 light-years from the center, out in the galaxy's outskirts. Now, when we say supermassive black holes, we're not talking about the same size for each of them. Their masses were estimated at roughly 80 million solar masses for the largest, 2 million for another, and about 0.6 million for the smallest. So one giant and 2 smaller siblings, all active, all pulling in matter through swirling accretion disks around them. Here's the part that made scientists sit up though. The most massive one, the 80 million solar mass giant, is actually feeding slower than expected. Meanwhile, the smaller one, at 0.6 million solar masses, is feeding so aggressively that it's exceeding what's called the Eddington limit, basically the theoretical speed limit for how fast a black hole is supposed to be able to grow. It's breaking the rule the textbooks wrote for it. So why does any of this matter beyond just being a cool discovery? Because it plugs directly into one of the biggest open questions in astronomy: how did the universe build black holes this massive, this early? We know galaxies in the early universe collided and merged with each other constantly. And when 2 galaxies merge, the supermassive black holes sitting at their centers eventually get dragged toward each other too. Scientists have long theorized that this merging process is one of the main ways black holes grew so fast in the early universe. But theory is one thing, actually catching it in the act is another. This is one of the first times astronomers have directly observed a system that looks like exactly that, a galaxy caught mid-merger, with multiple active black holes still finding their way toward each other. The 2 central black holes, the ones just 620 light-years apart, are expected to merge within the next few 100 million years. Which, yes, sounds like forever to us, but in cosmic terms, that's fast. And here's where it gets even bigger. When black holes this massive eventually collide, they don't just merge quietly. They send out ripples through the fabric of spacetime itself, gravitational waves. Researchers estimate that this particular pair has around an 82% chance of being detectable by LISA, a space-based gravitational wave observatory planned for the future. So this isn't just a snapshot of the past. It might end up being a preview of a signal we actually pick up one day. Now here's something worth sitting with for a second: this galaxy has a total stellar mass of about 1.3 billion suns. And these 3 black holes, combined, make up a genuinely significant chunk of that mass. For a young galaxy this early in cosmic history, that's a strange balance. It raises a question researchers are still chewing on: are these black holes growing because of the galaxy, or is the galaxy struggling to grow because of them? That question doesn't have an answer yet. Nobody's faking certainty here. This is still fresh, published just this month in the journal Astronomy and Astrophysics, and there's a lot more work ahead to understand what this system eventually becomes. But think about what we just did here. We looked 12.5 billion light-years away, into a galaxy that existed when the universe was in its toddler years, and we picked apart 3 separate black holes hiding in the glare of one blurry point of light. That's not a small technical achievement. That's astronomers learning to see something the universe had been hiding in plain sight this whole time. So here's a question for you: if 2 of these black holes really do merge in a few 100 million years, do you think the third one out in the galaxy's outskirts eventually joins them too? Or does it stay out there, orbiting on its own path forever? Put your guess in the comments. I actually want to see what people think. If discoveries like this are the kind of thing that keeps your brain busy at 2 a.m., you already know what to do. Stick around, subscribe, because the universe clearly isn't done surprising us. And that giant black hole feeding slower than its smaller neighbor, that's not the last time size is going to lie to us in this universe. More on that soon.